My name is Oleksandra, and today I'm going to present the work with the name Discovery and Analysis of 8 New Variable Stars from TESS Sector 57, which was done together with Dmytro Twardovsky as well. The study of eclipsing binaries gives us better understanding of this type of objects and possibility to investigate different processes in the binary systems. However, variability of numerous stars are left unnoticed and unstudied, mostly because of limited possibilities of on-ground observational facilities. Luckily, such instruments like TESS, Transiting Exoplanet Survey Satellite, can provide us with photometric data for hundreds of thousands of objects. This data has much higher signal-to-noise ratio and could be used in study of various objects. In some cases, it can lead to discoveries of variability of some objects previously known as non-variable, including completely new types. In this work, we report the discovery of 6 new and classification of all 8 eclipsing binaries. For our study, we used open access data from TESS Space Telescope provided by Mikulski Archive for Space Telescopes. We used photometric observations from sectors from 14 to 22, sectors 25, 26, 40, 41, and from 47 to 59. For separating maxima and minima extrema and determining the approximate period, we used a cold splitter developed by Dmytro Twardovsky. For recording the moments of maxima and minima, we used MAFCA software, which can analyze only one extrema for interval. So it was essential to separate extrema, one extrema for one interval, in order to do their future analysis. When the types of extrema were separated, we used this MAFCA software, which was actually developed by Katerina Andrich and Ivan Andronov for approximations of photometric data and recording the moments of minima and maxima. For symmetrical extrema, we employed VSAP and the Mikulášek methods of data approximation, and for asymmetric and general cases, we use polynomial approximations. After data was used to calculate approximate values for initial epoch, calculating more accurate values of eclipsing periods, and building the O-C curves. O-C, observed minus computed curve, is a method to study the period changes in variability of a star in the way of measuring the difference between observed moment of extrema and calculated moment of extrema, assuming the constant period. The resultant shape of the O-C curve could tell us about absence or presence of periodic changes in a stellar system, which could indicate the elliptical orbit, pulsating component, reflection effect, or even the third body in the system. We used observed moments of extrema measured with the help of MAFCA software and calculated moments of extrema, which were calculated based on the following formula, which is listed in this slide as well. So to begin with, I'll talk about the star with TAC identifier 1507, which was previously known as an eclipsing binary, but it wasn't classified, and the INSIMBAD, they didn't provide any classification for this star. So using the TESS data, we found out that the classification of this star is EW type, based on analyzing the phase curve and the light curve as well. As its primary and secondary minima has no big difference in depth, the property of the phase curve indicates that these two binaries are in contact and transfer mass and energy throughout Lagrange's first point, as the period of the stellar system is approximately 0.59 days. It probably places this eclipsing binary in a subclass of EW type. We plotted O-C curve for this star based on maxima and minima points. Overall, the value of O-C is fairly low because of clear extrema and the eclipsing binary. However, this shape of O-C diagram shows the presence of additional effects in the system. At the beginning, we have usual shape of O-C curves, points randomly spread on relatively equal level of the module of O-C obtained value. Then, starting approximately from t equals 2868, the points of both extrema are having bigger and bigger value of O-C, spreading away from the linear approximation with time. This property of O-C diagram probably shows us the clue of the presence of precession of orbit eccentricity in this eclipsing binary. Next star is a star with TESS identifier TAC 4557, which was previously classified as a non-variable single star. For our analysis of the star, we used data from one sector, TESS sector 57. The plotted phase curve for this eclipsing binary shows a plane flat maxima and sharp minima, from which we concluded that this eclipsing binary is EA Algol type binary. However, it's clearly visible that there are some deviations from general shape of curve, which probably sometimes is a result of imperfection of a TESS optical system, as it's seen, for example, from the left of a light curve. So we probably will need to do some data reduction as well in order not to include this incorrect data. But also, if we will look at the general light curve, we'll see that sometimes these variations are repeating. So probably it could indicate some pulsations in the system as well. So the O minus C for this star was plotted considering maxima and minima of the system. The absolute value of O minus C for maxima are significantly higher compared to values obtained for minima. The reason for it is the flatness of maxima, which sometimes causes the program to calculate the moment of minima with less accuracy, whereas sharp minima provide us with more precise results. Overall, the shape of O minus C curve does not indicate any unusual properties of this eclipsing binary for us. The next star, TAC 1985, was previously known as non-variable star. However, based on TESS photometric data, we classified this object as EA Algol type binary star, which is visible from phase curve as well. The shape of the light curve clearly shows the presence of pulsations on one of the components. However, it is not visible on the periodogram of this object. On the periodogram, we can see peaks of fluctuations, which shows us the binarity of the star, but the peaks which indicate the pulsations are not visible on it. And also the shape of O minus C curve does not show the presence of pulsating component as well. However, when we obtain this O minus C diagram for this object, we realize that the star has an elliptical orbit because of two parallel lines on the O minus C curve, which indicates that. So the next star, TAC 392, is classified as spectroscopic binary. However, more detailed classification was not provided. Based on plotted phase curve, we classified this object as AA Algol type variable, as it has flat maxima and sharp minima as well. Furthermore, the photometric data provided by TESS shows us the evidence of pulsating component, which is firstly visible from the light curves and phase curves of all sectors. The short periodic pulsations are clearly visible on maxima. Moreover, there are different pulsations detected visually. We plotted O minus C curve for this star based on minima and maxima data. The shape of O minus C diagram might indicate the presence of pulsating component, but because of a background noise, the particular shape of this curve is not visible. The points are randomly distributed relatively on equal absolute values of O minus C, which could not lead us to conclusion about classification of this object based on O minus C curve. However, the plotted periodogram shows us the presence of several additional periodic signals in addition to initial periodic signals from eclipsing binary system, which definitely shows us, which was actually obvious even from a light curve, that this system contains a pulsating component, which was not mentioned in the classification of this object before. And in future, we need to do some more studies of these pulsations in order to determine their period and to find the possible classification of this pulsating component in the system. The next star is quite interesting. It's TAC 2075, which was previously known as X-ray source. In our study of this star, we used TESS photometric data from sectors 41, from 48 to 50, and 52, and from 55 to 59. We built the phase curve for this star, which indicates that this eclipsing binary is again EA Algol type binary. However, this eclipsing binary has different unusual effects. Firstly, it has non-periodic flashes of different amplitudes, which are ejected from primary or secondary minima. As the source was classified as X-ray source, we propose to explain this classification as a result of these flares. As it also seen from a phase curve, the shapes of the primary and secondary maxima are changing over time and have different starting magnitudes, which indicate the presence of the hot or cold spots on the one of the components of the system, and also probably the reflection effect. Furthermore, the O-C diagram has really unusual shape for typical eclipse in binary. The shape is rapidly changing over time. Points are getting aside of the linear approximation, and then after some period of time are getting closer to the linear approximation again. On the O-C diagram of minima, points starting from sector 41, generally distributed as usually in classical eclipse in binary O-C curve, but it is visible that they're getting slightly aside from approximation. Furthermore, the situation is changing on the period of from 48 to 52 sectors, when the shape of O-C curve is getting aside from linear approximation even more. And then at the period of from 55 to 59 sectors, again, starting from quite standard distribution, points are getting aside for some time and then continue at approximately equal distance from approximation for the rest of the time. The linear approximation for O-C curve of maxima is more deviated from x-axis because of more precise value calculated from sharper minima. As it's seen from light curve and phase curve, the shape of both primary and secondary maxima is changing with time, and sometimes periodic flares are present, which makes determining the orbital period of system from minima more reliable. Firstly, at the O-C diagram of maxima, points are getting closer to linear approximation, then starting again from sector 48, data point starts to getting aside from approximation. Moreover, starting from sector 55, points are spread aside of approximation again from the position where initial points from sectors from 48 to 52 are distributed. On the period of from 55 to 59 sectors, O-C curve is getting aside of linear approximation, whereas having additional curves. At this moment, for us, it is not really clear which effect could indicate such as unusual shapes of O-C diagrams. However, it could possibly be the result of changes of shape of the primary and secondary maxima, and possibly strong reflection effect. Next star with identifier EIC 2026 was classified before as a single non-variable star, but the TESS light curve shows clearly that this is a binary star. After we build up a phase curve for the stellar system, we concluded that this object is EA, alkyl type eclipse in binary. Moreover, this star has interesting effects. The shape of a light curve is rapidly changing over time. It can be seen from the two examples of a light curve from sector 57 and sector 58, which possibly indicates the presence of pulsating component in the system, even though if it exists, it should have no short periodic pulsation as it's seen from the light curve and phase. However, the pulsations are not visible on the periodogram as well. If we'll look at the periodogram, and also if we'll analyze the O-C curve of this star, it's quite strange, and the shape is really unusual of it. But in our opinion, it's that because we need to do some more analysis on this star, because we couldn't determine really precise value of period for this star, and we need to do some more work on the stellar system in the future in order to build up better O-C curve for this stellar system. Next star, EIC 6510, was also unknown as a variable before. It was known as a single non-variable star. After analyzing the TESS data, we determined the type of this eclipse in binary as EWV star. And as we didn't have lots of data for this star, as you can see, we used only sector 57 for this star. We couldn't find we couldn't build up the good O-C curve for the stellar system, so it looks quite strange. So in order to find more precise period, as you can see, it's not really precise so far. We need to find some more data to analyze for this star and to get more precise value for the stellar system. So the next one, the last star.
Sorry, you're running out of time, so can you go to conclusions, please?
Okay. So as a result, in this work, we presented the results of analysis of 8 eclipse in binaries. Among them, only 2 of them were previously known as variables, and 2 of them, like TAC 2075 was known as X-ray source, and TAC 1606 was known as a white dwarf candidate. Moreover, none of them had the classification before. That's why we provided our hypothesis of which types of objects they could be. Thus, we report the discovery of variability of 6 stellar system and classification of all 8 objects. However, classification of some effects are not clear so far. Some of them have additional interesting effects, such as possible long-term pulsations, reflection effect, and non-periodic flares. In addition, we calculated the period, initial epoch, plotted and analyzed O-C curves for maxima and minima for most of them, and concluded with the classification for most of the stellar systems. Thank you for your attention. I will be happy to answer your questions.
Thank you very much.